Good evening, friends. Hope I am audible. Could you please confirm in the chat box? We'll start the session. So it's already 7. So today we are going to learn about the PyTorch, which is helping deep learning in object detection, object classification, and object segmentation. So we'll try to understand how we got into the deep learning concept. Earlier, we used to have traditional programming method, that is machine learning, which is for supervised, unsupervised, and semi-supervised. Where the traditional programming was for structured data, and there are few traditional machine learning algorithms which is working for the other data which needs to be converted to structured data and need to work on that. However, these traditional machine learning programs are not giving accurate results. Hence, it leads to a discovery of neural network or deep learning concept, which deeply helps in understanding unstructured data. Unstructured data like images, text, sound, audio, when I say sound, and you have video. So these unstructured data is then dealt by deep learning, and also it performs very good with respect to a complex data where it is faster when compared to the traditional model, as well as accurate. Hence, the deep learning plays an important role in artificial intelligence working on complex problems with faster rate and with good accuracy. So when I say neural network, concepts of neural network as well as the deep learning, one and the same, where the deep learning has its features without supervision of human, where it understands from the training. So understands from training. So we train the model, and model is going to understand, and if there is any object, it is going to detect or classify or understand what the image is all about with more quicker way. and accurate. Hence, the traditional method what we are following goes down. So what happens in the traditional machine learning program, and what happens in deep learning program? Here, in traditional machine learning program, the programmer plays an important role. The role of programmer is so important that when he is designing the model, extremely specific in telling the computer or a machine, telling what type of things should be looking into. So the programmer is writing a program by concentrating extremely on specific data or specific features, what we can say, to the computer, what all types of things that you need to concentrate. So that is what the programmer is all about doing. Whereas deep learning builds his own features, the feature set, without the intervention of human, as I said, in a faster and accurate way. So that is the difference between traditional machine learning program as well as deep learning program. So today's agenda is to understand that, and we started with that understanding the introduction to deep learning, and we'll learn how PyTorch, which is a library or a open source, which is helping indirectly or helping directly to the deep learning in performing object detection, classification, and also segmentation. So we'll discuss all the three and we'll tell you how it is important, playing an important role in deep learning. So for that, we'll try to understand what is the introduction part, that is deep learning. So when I say deep learning, let me tell you that. Let's say example, we have a toddler, does not have any idea about how dog looks. However, the parents are going to train about the features of dog. So toddler has been trained by the parents and understand the features of the dog and recognize that for the first time it is a dog. So first time it recognizes the dog, and if there is one more picture of a dog, it easily identifies the dog. So it need not to be the same picture. It could be the different image. However, the features remain same. It has 4 legs, tail, and the body is heavy, and it has a face, and it is barking. So you'll come to know all these features by a toddler and then try to recognize the dog. So the image of the dog varies The dog will be sitting, dog will be running, dog will be barking. The other side of the dog, the top view, side view, front view. There are different views of the dog, but still it is identifying the feature based on the experience or based on the training that has been done. This is what we call it as deep learning. So here the toddler is deep learning model. So it is predicting based on the training that has been given, which imitates the way of human understands or gain the knowledge. Always human gain the knowledge based on the experience. Every day we'll learn and we'll understand and we'll gain the knowledge. Like the same, the model is also going to learn, understand, and based on the experience with a enormous data, so it is going to learn and get the knowledge. So when I say that deep learning, it has two things. One is training the data, another one is learning from the experience. So deep learning procedure is always training the data and always learning from the experience. So we definitely understand and try to figure out the solution when we learn more things and gain the same. Where deep learning performs classification, the task of classifying on several complex data. We have several data like images, text, sound, and video. So it is going to classify or segregate based on these data, which are referred to be as complex data, and understand from that, get trained on that, and then learn from that, and then provide us the solution in future if you have any other images. So there are few different functionalities that we need to see when it comes to deep learning. When I say functionality, it manages the data, it trains the data, and it will be efficient when the data is more, when the data is large. Larger the data, more efficient, which impacts on the decision making. So predicting more accurately plays an important role in this deep learning. So to support all this or to perform all these activities, we do require the support of few things that are libraries or packages, or we can call it as modules, which are written using Python programming language. That is helping us to perform so many things. For example, if I say I need to prepare some dish if I need to prepare a dish, you need to have a proper utensils. If you don't have a proper utensils and proper resources, even if you tell or give a menu of it, how to prepare, it will not be good as you prepared. So you need to have a tools, appropriate tools to prepare a particular dish. Only then you will say that we have prepared a dish and it was delicious. So one of the kind of packages, or I can say libraries, which is helping deep learning is PyTorch. So PyTorch was recently developed by the team of research work from Facebook. So there are a group of people who worked on PyTorch and came up with a solution, and has been informed that this is a framework which is enormously played an important role, preferred for coding and working with deep learning. We'll see how and why it has been referred to be as enormous or important framework under deep learning. That is the main objective of this session. Initially, it got developed in 2016, and the stable version has been released so far 1.11 recently, last month, 10th March 2022. And you can have a repository, you can just make a note of it, github.com/pytorch/pytorch. And we can't say deep learning is ultimate or deep learning is an emerging trend without the use of these tools. And it has been become very easier when I say I'm so sorry. So deep learning concept has become more easier with the help of these tools. The coding, the implementation, everything becomes simpler. Now we'll try to understand what is PyTorch, what are the features of that, and how it is going to bridge between a traditional machine learning NumPy. It looks similar. It is also kind of data structure. It is a kind of data structure. Overcomes the drawback of NumPy, or I can say the advanced version of NumPy. And also we'll see use cases for object detection using PyTorch, object classification, which we have come across using some machine learning algorithms for detection and classification. We have some pre-trained models. We have some pre-trained models. Hence, we'll see that how these pre-trained models are helping with the help of PyTorch. It is faster than any other pre-trained models or working on different processing units. And let me tell you that PyTorch works on both GPU machine as well as CPU machine. So graphical processing unit. So on GPU machines, PyTorch will be accurate and more efficient. However, traditional machine learning algorithms will work on CPU. So we'll also see how it is going to be accurate and more faster. So we'll understand what is PyTorch. So as I said earlier, it is a framework or a package or a module to compute a scientific computations, a complex things, which is computing a complex things. And it is of Python based, where it has two things to be concentrate, which I say that it is an overcoming of replacement of NumPy, and it is more flexible than that and more speed, or I can say I've told you faster. Hence, indirectly, we'll say deep learning is faster. Since PyTorch is working faster, which is replacing NumPy, hence we say that it is, excuse me, it is flexible and speed and faster. So NumPy is working on, excuse me, GPUs. At the same time, PyTorch also works on GPU, and it is going to train different neural networks, and it is going to build the neural networks, which is helping in image classifier object detection models. So we'll try to understand that. So before that, I just need to tell you a few features that are required for that are there under PyTorch, which I have not mentioned here. It is actively used in the development of Facebook for all its deep learning concepts, and easy to use, and it is dynamic computation. At every point of code execution, the graph can be built and can be manipulated during runtime. Hence, we say that it is dynamic computation graph. It is faster and also feels native, which belongs to the Python, and easy coding. As I said, easy to use. It is faster. It feels native. It is easy to code. Fast processing. And it also supports CUDA, that ensures the code is run on the GPU, thereby in turn decreases the time that needs to run the code, and it in turn increases the performance. So it reduces the time taken to run the code. When I said it is faster, when I say time taken to run the code is less, the performance obviously increases. So the performance is based on the time taken to run the code. So how do you install PyTorch? So you have a package pip install PyTorch, and you'll install that. You'll just make use of that. So we'll try to understand the simple examples. So here I have import torch. So for Python, you just need to import, where you will be writing pip install PyTorch. So you'll execute this and the package will get installed. And you import the package PyTorch. You also have import torch vision. And you also have NumPy, neural network, torch for neural network, and for transformers. So we'll discuss what all things do required and why we have imported all these. So we'll create a tensors. So tensors are also blocks, memory blocks, which can be connected each other. It is also kind of data structures, which is having some memories, same way as Python, NumPy. So when I create a three variables x, w, b, I'm creating with respect to torch dot tensor. So this block has been created for x, and this block is created for w, this block is created for b. So when I create this tensor, it creates a floating point number. So 1 dot is almost equal to 1 dot 0, which is of floating point. When I create a particular value, let's say example, I just need to create 1, 2, 3, 4, 5, 6. Then you can say that you need to create a torch dot tensor of 2 by 3, which is of 2 rows and 3 columns. So you can create a particular variables. I'll just show you like this. You can see here import numpy as numpy and np. So np dot array. So we have an array of elements 1, 2, 3, 4. So we are converting that array numpy array to torch tensor. So torch here referred to be as numpy and tensor here refers to be as numpy and tensor here refers to be as array. So you can relate that. So when I say torch from numpy, you are converting and it will be stored in y. When I say that convert the torch tensor to numpy, you will say numpy. So this is the keyword that will be used to convert from numpy to torch and torch to numpy. So when I execute what is the value of y, when I execute this, what is value of y? I'll execute this. It is taking time to connect. Okay. Initially, I need to execute these packages, torch, and then I need to execute this because the torch dot from numpy. So when I execute y, I'll be getting the value tensor of 1, 2, 3, 4, 5. Whereas when I execute z, you can see you will be getting array of 1, 2, 3, 4. So you have difference when compared to y and z. So we'll see this later. Object classification and object detection. So we'll try to write some more code to understand how torch is working. So that we'll be understanding how PyTorch is created or how it works. So let me create one more saying that P1 equals to torch dot tensor of 5 dot. So what does it mean? So when I create, I'll be finding the some value. So when I call what is T1, I'll be getting the values like tensor of 5, which is with a single number. So it is a single number. And after that, I create a T2, that is T2 with torch dot tensor of, will have two numbers or three numbers or more numbers. So when you are writing with those multiple numbers, you just define it with respect to bracket. When I execute this particular value, what will be the value of T2? It will be 1, 2, 3, 4, obviously. Now, what will be the type of this? When I give the data type of T2, it gives torch.in64. All these are integer. So when I say, if I say one element is float, then I'll be getting all the elements has been converted to float. So when I execute this T2, what will be the value? You can see that 1 has been converted to 1 point and 2 point is remain same, and 3 converted to 3 point and 4 converted to 4 point. So this is a single dimension vector. So we know how vector has been defined, and you can see that how a single dimension vectors has been defined. Now, how do you manage to represent 2D? How do you create a 2D? So I'll just write T3. Same thing, torch dot tensor. So within bracket, you have 1, 2, 3, and you have comma. So 2, 3, 4, come outside and give again 4, 5, 6. So this is what we learn to give the value. So torch.tensor will be creating T3, which is of 3-dimensional. Not just because we have 3 elements, it is again we can increase, but here we have 3 rows and 3 columns, and it is number of dimensions that has been increased. And when I say T3, the value is displayed with respect to this dimensions. Tensor 1, 2, 3, 4. If I make one element as float, obviously all the elements will be getting changed to that particular float value. You can see that all the elements will be in float value. You need not to worry about the other elements, need not to take care of about the other elements. So we call this as a 3D tensor, which is a kind of matrix. So when I write T4, let me write one more, T4, it is of a different way, torch.tensor, where I'll be writing an element 10, 11, 12, comma 13, 14, 15. And again I'm coming out of this, and again I'm writing again with respect to 2, 3, 4, and inside this I'll be having 4, 5, 6. So it is giving me an error. So you need to have a square bracket, and at the end you need to have one more square bracket. So it does look like this. This is one, and the other one is like this. So you have two things where it is displaying you with the elements. See, you can see how it looks. Now, here you can say what is the shape of this T3. What is the shape of this 3? It is 3 by 3. You have 3 rows and 3 columns. Now, what is this shape? The shape of T2 The shape of T2 is 4 elements. You have 4 elements. So what is T1? The shape of T1? It is no shape. We have only one element and it is of no dimension, 0 dimension. So when I take what is the shape of T4, what do you expect? The answer that we got is 2 comma 2 comma 3. That means you have a 2 set. This is one set and this is second set. We have 2 set of 2 by 3 matrix. So this is rows and columns 2 by 3 and it is of how many set. So let's say example, if I add one more, I'll just add one more. I'll just copy here, comma. I'll just add here and I'll just make what is the T shape. Now you can see that it has been increased to 3. I've added one more. So if I add one more and I'll just execute this and I'll execute this, you can see it has become 4. So this is how it works, the PyTorch, when it comes to a tensor. Now we'll understand how it is helping us to calculate this x, w, b and whatever I have told. So here I'll not make use of this. X is torch tensor of, I'll just change these values 3 and w is with 4 and the 3 is of 5. I'll just execute this and it gives you the value. So the value here, whatever it is giving, is with respect to the equation that we have written here. So what is the equation that we have modified? What is the value of W? So the value of W is 4. The value of P is 5. Okay, what is the value of X? It is 3. So when you individually get the values of each time, so I'll just execute this. Now what is X? Tensor of 3. So what is Y? You can see tensor of 17. How did you get Y as 17? Because you substitute here. W value is 4, B value is 5 and X value is 3. You substitute, you'll be getting 17. Now Y is 17. What is W? The W is, we have taken 4 and tensor of 4, that is W, and the B is 5, that you all know. So you build a computational graph for Y is equal to Wx plus P. Now what is this Wx plus P? So Y is equal to Mx plus C. You know this. So how do you calculate the slope? Slope is nothing but the rate of change. So the rate of change is nothing but derivative. So you perform the derivative with respect to the change of x. We call it as dy by dx. When I say what is the value of dy by dx for this equation, we don't know what is m value and c value, but still when I give y is equal to mx plus c, if you find dy by dx, you will be getting only the value m. So when you perform dy by dx, you will be getting m. Okay, so at the same time, when you perform y with a range of change of c, this one, so y with respect to c, what will be the value? You will be having 1. Why? This is only c. So what is dy by dx of x? It is 1. So same way dy by dc as 1. So dy by dx as m, dy by dc as 1. What is dy by dm? So when I do with respect to m, you will be getting as x. So here the grad refers to the gradient or the derivative or the rate of change. So that means indirectly it is computing dy by dx. So in traditional machine learning model, we need to programize everything to perform this by mathematical equations. We need to give the derivative of x, y, and then see the changes. But here, if I specify x dot grad, then the equation y is equal to wx plus b will be performed with respect to x, and it will calculate what is dy by dx, that it will be w. Let's say example, we have dy by dx as 2x, 3x, or lx. Whatever we have as a product rule, we'll get that value. So we get wx. So when I perform dy by dw with this, you'll be getting x value. When I perform dy by db, you'll be getting 1. So same way we are getting those values. So the grad is helping us to perform, which is helping with the help of PyTorch. So when you compute the gradient, you know about backpropagation algorithm? Backpropagation algorithm, which will be done in neural network, where you will be having backward and forward. It will be done. So where you do this with respect to change of weight, and you will be having a rate of change for that particular weight. So you calculate y dot backward, which performs the gradient x dot grad, w dot grad, v dot grad. So since I have not mentioned the grad here, it requires grad to be 0. That means x is considered to be as constant. Hence, you are not getting the value. Let's say example, if I makes that as a requires grad to be done, so then I can see it will work fine, and you will be getting 4, 3, and 1. So x gradient, when I do it with respect to x, you will be getting value 4 because it is with 4 into x. So here 4 into x, you will be getting value 4. So as per this equation, as per this equation, you will be writing y is equal to 4x plus 5. Don't apply the value of x, just apply what is dy by dx. You will be getting 4. Now, you apply x value here and don't apply w value here. So, you will be getting y is equal to w, x value is 3 plus 5. So, you perform with respect to w. So, you will be getting 3. Now, whatever value you apply as w or x, this will become constant when you are doing with respect to b. So dy by db equals always 1. So perform derivatives is with the help of tensors, that is PyTorch. So this simple calculation has been given and it has been performed with these 3 lines and you are getting it. That is the simplicity and faster and speed accurate with the answers. So the rate of change is obviously required in deep learning because we are calculating the minimum cost. You can see that the weight. So with respect to the weights, we are calculating the loss function. So we need to have as minimum as the loss value. So when you want to find out the minimum value, you need to calculate the derivative. So partial derivative is required. Hence in the neural network or deep learning concepts, to reduce the loss function or cost function or error function, we are performing derivatives. Hence these derivatives are helpful in calculating with the help of PyTorch. So this is a simplicity of a PyTorch that is helping us to understand a bit in knowing different things in deep learning. So we'll move to the next topic, that is how object detection uses PyTorch in detecting the objects and naming it. So here we have 3 things. One is object detection, object classification, and object segmentation. So the diagram shows you what is classification, what is detection, what is segmentation. So first you will be having semantic segmentation. It says what all different colors will be different objects. And it will identify the classification with the localization with the cat. So the complete will be detected as a single object, that is a cat. So when you have multiple animals or multiple objects, it will be identified as different, and it has been referred to be as object detection. Whereas this occupies more space. You can see that the space here is all unwanted. So this space is unwanted. So you can see that this space is unwanted. When you are identifying the object, some spaces are unwanted, and it is something like it is taking more time to compute all these spaces also. Don't you agree that it is taking more time to compute everything? See how many steps, how many computation time it is wasting. So inside this box, so this box is forming object detection. So each and every pixels will be calculated, and it is wasting time in identifying inside this box in identifying. But when you have a particular, I can write that by using different color. So when you have a particular shape which is telling that this features is cat, So that is what instance segmentation. So this understanding, the red color is dog, green color is also dog, and the blue color is cat. So when you have a multiple object, you will be having object detection and instance segmentation. So it computes less time, it takes less time, and it takes more time in computing because you have other things to do it. So to reduce that, to overcome that, we use instance segmentation. So I'll show you a code so that you can understand that. So this is a part of object detection using PyTorch. So we'll show you. So how classification is done? So we have many objects. Let's say example, the pedestrians are crossing the road and all the vehicles are standing, and you will be having huge building, and there is a aeroplane that is going on here. So I need to differentiate what all these things that we look into the object. So I need to say that the people are walking, people are walking, and this is a car, and this is a building, and this is an aeroplane, and this is a building. So in this particular image, what all things you see, and you need to segregate that classification based on the features, whether it is aeroplane, car, building, or a person. So like this, you have a plenty of categories which is under this cipher 10. We make use of this data set and try to understand and classify based on the image that we have. So let me give you some idea with the coding part so that you will be understanding. So it has been already run with the coding part. Okay. So here you can see from the initial I'll take. So we have used torch and torch vision, and it has multiple models for detection, and it is using fast RCNN for detecting the object, and it is using pre-trained model, that is ResNet, and this model is having this method to detect any of the image, and it is going to download the image file, and it is going to evaluate that. And we have these many categories I've told you, right? Person, bicycle, car, motorcycle, aeroplane, bus, train, truck, boat, traffic light, baseball bat, gloves, skateboard, fork, knife, spoon, bowl. These are all some of the few categories that we have taken, and we give some image, and it is going to learn from the features, and it need to segregate or classify and detect what it is. If it sees in the image, if you have a bird, then it needs to give a label as bird. So for that you do required pill, that is image library, and it is going to have some predictions by transforming the image. So we'll be having images, and those images need to be converted to the numbers with the category. And once you have that transform, the image has been transformed, you will just pass the same image to model it. So model of image, where you have done the predictions, you want to do it with respect to fast RCNN with the help of torch vision. And here the torch vision is going to compare it with the instance that you have. So here it is going to identify which category it has belongs to, and we are telling that to predict. And based on the image that you have given, it is going to print what is that image. So it is having a object detection method. So it is going to detect that and it is going to display that. So we are creating a label and we are creating a box for that. What image has been identified in what level. So I've given this image and it is of consist of all cars. So it is identifying and making a box on that particular image, mentioning as a label as car. You can see on all the images you have made mentioned as a car. So this is what PyTorch is helping within the no time, and you don't have any risk of writing this code, lengthy codes. So I'm giving another image where three person are standing and looking into one place, and it has been easily identified that these are the person and it has been learnt. And I'm again giving a different image where it looks similar, but still it is recognizing this is a cat and this is a dog based on the feature. So this is what a deep learning is doing with the help of PyTorch. So when I say it is doing with the respect to PyTorch, how do you say it is giving a better detection and better classification of an image? I'll just show you that. We have that at the end. So we have one of the comparison where the model is given to CPU and also given to GPU. So this model runs under GPU, and how it what time, how much time it takes to run in CPU and how much time it takes to run in GPU. So we are calculating that. So we are checking the inference time by passing the image and making GPU as false and making it to send it to the model and evaluate that and put it in the image and transform that, and that transformation, once it is done, if it is GPU, you'll have CUDA, model.CUDA, and image is equal to image.CUDA. And if it is else, then it is model becomes CPU, runs in CPU, and the start time end time is calculated, and you'll be getting the CPU time as well as GPU time. Based on the check inference time, you'll be calculating whether it is GPU true or false and getting the value. The value which you got, you can see that average time taken by the model to predict the image. So it is taking 0.214 seconds, whereas CPU is taking 7.16 seconds. Can you see this imagination? That is, could you please imagine that how strong GPU is all about? So it is detecting the image so fast and accurately. It has been given so fast and it has been accurately identified. You can see that it has been here the images of two images, or two animals, that is one is cat and one is dog. It has been identified. Here you can see it has been truck, car, and this is a person. It has been identified. And here also you can see that these are the person, and there is one remote here that is also identified. And the things that we have trained with the Coco instance dataset, hence it has been detecting. And here also you can see that it is a bird, and here also it is saying that the part of truck. Can you see that blue color? So this blue color is instance segmentation. So outer part is green color, which is labeling it, it is object detection. So we have two things. Here in this image, a person with bat, ball, and this has been referred to be as bat, but it is not a bat, it is a wicket. And it has not been trained. So however it is fined lengthwise, it will be treated to be as bat. So we are not sure that 100% it will be efficient. You can say that it is going to identify some percentage. You can see that it has been detecting cat and dog for this image. So for that, various methods are being taken to transform that. You see that this has been transformation, and then it makes it in the values, and this value has been taken considered to be as features of the image. So when I give an image, you will be having the value. So when I consider to be as a matrix, so each single box is referred to be as pixel. So this pixel will be converted to numbers. So when I say this image has some value, that means you have some numbers. So if you find this number in the image, then it means that it is a dog. So here if it is finding something, this pixel value is matching with the cat. Then it says it is cat. So like this, several pixel images group together and it is formed, and then it gives you the prediction based on the trained model that we have given in the training. So here we have training categories names. So in this name, it will pick up and then it will give you the output. So PyTorch is helping us in no way, getting us in short span of time. You have seen that it takes hardly zero 0.2 seconds, and it takes hardly about 0.214 seconds and 7.12 seconds. You can see the difference the GPU is taking and CPU is taking. So this is better when compared to CPU, the normal CPU, and it is faster, it is accurate, hence we go with this. So how do you say it is faster, accurate? With the help of PyTorch. So moving forward, PyTorch is going to be used by the companies, and we have trainings on this. We have several projects on this. We try to work on that. Hence, we are with the global trend, the global requirements. We always ourselves keep on updating, and we train the same on the requirements which is required by the global. So if you mention that you know this framework, immediately that will be reflecting on what projects you have done using these frameworks. So once you mention those, it will be highlighted and given preference for the candidates, those who know this kind of frameworks. And the opportunities will be more when you got upgrade yourself as per the requirement of the company. So hope you understood this. Kevin, I just need you to mark your attendance in the link which has been given so that I can get the email ID from that. So once I get the email ID, I can share the file. Is that fine now? And also the participants, those who are attending, so they can share their feedback and show their interest in liking the Facebook pages of 360DG TMG, LinkedIn page, and as well as YouTube, where you will be finding the videos of our seniors who deliver the current trend technology topics, where you will get more information. So we are very active in LinkedIn, YouTube, Facebook, and you find all the things, all the links in the chat box. You can go through that, you can like this, and then you can encourage for us to proceed with the new topics, the current trend topics, where you will be getting benefit which in turn required as per the global requirement. If you have anything to discuss, you can just mention in the chat box so that I'm here to help you in explaining the same. So this will be used enormously in the field of deep learning, artificial intelligence, where you are finding the objects. Let's say example, you are identifying an object and identifying the number plate of an vehicle, identifying an animal, and identifying some diseases from the X-ray report. Usually the X-ray report or the reports, medical reports will be scanned, and you need to diagnostic that. If the model has been already trained, it will be very helpful to diagnostic that within no time and without doctor intervention. So hence there are various fields wherever you have these categories like involvement with respect to the image, detection, classification, there you do require these kind of things. I would say that it is very much required in all the fields like healthcare, medical, defense, education, constructions, lifestyle, everywhere. And there is one more question from the participant Helmi. Keras is a part of TensorFlow. It is TensorFlow has been declared voluntarily that it is a package, a permanent package that will be used. So you can't say that difference between Keras and TensorFlow. So you can either segregate as PyTorch and TensorFlow. So preferable you just go as per your problem statement. Only then you can just sort the implementation, because when I say the same problem can be implemented both by using PyTorch, TensorFlow. However, the data involvement or the data which you have need to be analyzed, and your problem statement should also be there accurately so that you can just use the frameworks. So appropriate tool usage skills also required. You can also try with both and can come to a conclusion which is better based on your problem statements. So deep learning nowadays uses both Keras as well as PyTorch. Keras on different things, PyTorch on different things. So if you learn both, you will be upskilled. You are more skilled as per the requirement in a recent technology trends. Anything else want to discuss? I hope I answered your query, Elmi. So We would love to hear from you. If you like the session, please write us review. The Facebook link has been given and the Google link has been shared in the chat box. Please give your review so that we can motivate ourselves to come up with the new topics that will be delivered for a couple of hours, so that we'll be motivated to come up with more topics as required by the industries. You're welcome. And if you have any doubts, any questions related to the topic, you are good to mention in the chat box, or else we can wind up the session. Need to understand a basic problems, need to code from the basic, and need to work on different problem statements, and then we'll get master into it. And one thing I can confirm you that it is not so difficult when compared to machine learning, where we write our model from the scratch, whereas these pre-trained models as well as the frameworks what we use as well as the codes are open source and it is easily available in Google. Only thing, you just need to work on those codes which are available as per your convenient, as per your problem statement. You need to modify those codes and need to work on it. So as and on, if you work on different problem statements, different scenarios, different criterias, you will become master. Thank you so much, Noor. Is there anything else, Kevin, Helmi, and Noor, so that I can answer you? Thank you so much. I wish you could explore more on this with this basic idea, so that you got an importance of PyTorch on deep learning for object detection, classification, and segmentation. And please go forward, look into that, explore some of the information so that you will be getting benefit out of it. Thank you so much for your time and patience. We look forward the same support and same active participation in all the webinars that will be conducted by 360 TMG. And I would request your support by liking our social media, Facebook, LinkedIn, YouTube page, which is mentioned in the chat box. Please subscribe to our YouTube channel so that you will be getting more benefits through video sessions, pre-recorded videos that might help you to get the knowledge. Thank you so much. Have a nice time. Stay safe. Take care. Bye.